Well, hey there, folks. So last week we did some looking at brushed and brushless motors and how they work, how we can take a single strain of electricity into a motor and how that's actually going to be able to create some spin on an axle and using the electromagnetic forces of that system. I think it's a pretty ingenious that brushed motor is a pretty ingenious design, and it's something that we've obviously used for forever. Brushed motors are still extremely common, and the brushless motors very efficient, a little bit more sophisticated. They do take different kinds of speed controllers in order to take a look at that. So what I'd like to do today is to have you think about how can we control the speed of those motors. So just powering them up and having them go full force, that's great if that's what you want. If you have a device, and there's a lot of things that do that, turn on an electric fan, boom, it's going to be going on full. But what about doing something that's going to be a little bit different? So what I wanted to do is just demonstrate a couple things using the Tinkercad website to kind of show what's going on. So what I've got going here is just a 9-volt battery powered onto that particular breadboard. And could just wire up directly to the positive lead on one end. Looks like that's a go. Uh, as this freezes, good timing. And there we go. So we've got the power side in, and we'll do the negative side as well. Probably should color these so that we know exactly what we're dealing with here. This lag is a little problematic. There we go. Same thing on the other side. Sometime today. There we go. And we have that. So now if, again, I'm just going from power to power, and that should be when I start the simulation, we should be having, this thing is moving around 17,000 RPMs as we're going through that particular circuit. All right, and that's the only thing it can do. All right, if I were to stop it and switch these leads around, now we're going to go to the negative. This one's going to go to the positive. We're just flipping the polarity, and now it's moving in a negative direction. Same rate, mind you, but a different, but moving in the opposite direction. All right, so that's what's referred to as changing the polarity of a particular motor. On a DC motor, it doesn't matter. Just swapping the leads around is not going to hurt the motor at all. It's just which way does that thing spin. If you watched one of the videos last week, they were talking about the left-hand rule, and that's what governs which way does it spin. That left-hand rule is what does that. So let's say we wanted to control that. Well, one way we could do it is simply by restricting the flow of electrons. So if we put in a resistor, that's what a resistor is going to do. And if this is a 1 ohm resistor, if we did this, if we get rid of that guy and this guy too, what the heck? And now I'm going to power up one side of this resistor. I might need to reshoot this so that I'm in a spot that doesn't take quite as long every time I click. So I'm going from power to one side of the resistor. The other side of the resistor is going to go to the positive value, and I'm going to go back to the negative to ground, and that should be black. It should be red. There we go. All right, so now what's happening? Well, I'm going from power, but all of a sudden, this is like again, if you think of it in terms of water, I went from a big pipe to a smaller pipe. And so it's how much resistance am I creating in that particular circuit. So now when I run it, I get no power. There we go. No, so we're spinning, and at 1 ohm, it's spinning almost without any kind of resistance that's going through. So 1 ohm resistance is not very much. But if I were to switch this to 1,000 ohms, now all of a sudden, notice what happened. That changed rather drastically. All right, and so from 17,000 down to 1,000, and I can keep going up. I can keep on changing that. So if I made it 100,000, 100K resistor, and run that, now it's moving at 11 RPMs. So I can do that with just putting in a resistor. I can't modify how fast it goes, but I can control. So if that's way too fast, I want to restrict the flow of electrons, simply put it in a resistor. It's like making a smaller pipe. The flow of current through this motor is going to be significantly reduced. All right, and I could actually, if I wanted, I could test it out and see what the amperage is on that. The other thing that I can do is, well, what if that's great if I knew that I always wanted to have the thing run at a given rate, but maybe I don't necessarily want to do that. So what I can do as well is I can power up a potentiometer. This is a variable resistor, and I have the ability to, perhaps that has to be running. When I turn the dial on the potentiometer, it's able to increase the resistance. So very little resistance on one end, very high resistance on the other. All right. And the way that I would do this is I'd power up one side of I need to stop the simulation, power up one side of the potentiometer to power up the other side to ground. So now what I have is, sorry about that. What I have now is the potentiometer itself it has power, and then, well, what comes out of it? That's where that variable speed aspect comes in. And this guy I'll make black. So now I have a second motor, and what I'm going to do is I'm going to go from the middle prong of my potentiometer to the positive side of my motor, and now I'm going to go back to ground. That'll work. So now I'm able to power up this motor, but the electrons have to go through this variable resistor here, this potentiometer. And when I do that, that should affect the flow of electrons through that. So right now the dial's all the way down. So I'm not putting out any amperage at all on my out of this potentiometer. So this guy is not spinning at all. But as I increase it, it is going to increase. Now, this is not the best way to control a motor. So I've turned the dial halfway around, and I've only gone from 0 RPMs to 12 RPMs. That's not going to get a lot of work done. If I crank it all the way up, there's the 17,000. So you can see that it's a geometric output. I don't have to move. Just a very little range here where I could control it. So that's why you typically do not see potentiometers as a way of controlling motors. They're just not as precise. The other problem with it, when you start to do that restriction of electrons, these resistors, whether they're the single resistor that we were doing up here, or a variable resistor such as a potentiometer, they get real hot. So we're going to lose a lot of effectiveness as a result of the heat that's generated from those resistors. So instead, a better way to do that is with a speed controller, and a speed controller uses something called pulse width modulation. I was hoping, and I'm still looking for a way for you to wire up a speed controller, and that pulse width is really kind of understanding that is the next step. So there's another Ed puzzle that I've created. Please take a look at that so that you understand exactly how that pulse width works, how we're able to control things. And again, what we're doing in that case is that we're not, instead of changing the flow, the rate of electrons through a circuit, when they come out, they're coming out full. It's really the length of time that that we're using as a way of doing that. So that's that for just a quick overview of resistance into a motor. Next step is to take a look at PWMs.